Hello, so let's discuss today the fifth chapter of Aviation Meteorology, that is humidity. So, humidity, water vapor is always present in air to greater extent or lesser extent in troposphere. This water vapor plays a very important role in all atmospheric processes. Water evaporates into the air from ocean, lakes, river, vegetation, etc. It ascends and forms clouds which causes precipitation. The water cycle is thus completed. So it's simple, right? So water cycle is what you have already learned in your younger classes and all. So water vapor in hot air contains more water vapor than colder air. Then water exists in three phases as we have already discussed. The gaseous form is water vapor. The capacity of dry air to hold water vapor depends largely on temperature and to some extent on pressure. Higher temperature, higher is the capacity to hold air. That is, warmer the condition is, atmospheric condition is, it can hold more water vapor. Various terms used for describing water content in atmosphere: dry air, moist air, saturated air. So dry air, the air which contains no water vapor, is called dry air. Such an air may exist in upper troposphere or stratosphere. Moist air, the normal air that we breathe, is the moist air. So it is also known as unsaturated or dry air at the existing temperature and pressure. Saturated air is like a sponge which can absorb certain amount of water and no more. So when the air holds maximum water vapor, it is called the saturated air. And we can measure humidity by the instruments psychrometer and hygrometer, and it is recorded by hygrograph. So we classify air on the holding of water vapor on three: dry air, moist air, saturated air. Then the measurement, how to measure humidity by using hygrometer. So next is vapor pressure. Vapor pressure, the partial pressure exerted by water vapor in air is known as water pressure. So if P is the total pressure of air and vapor pressure is E, then the pressure of dry air will be P minus E. Then now in this session we are going to deal with certain terms which may feel confusing, but it's quite easy when we revise regularly, okay. So now saturation vapor pressure. So it is the pressure exerted by water vapor when air is saturated. So saturation vapor pressure. So you know what is vapor pressure? It is the pressure exerted by water vapor on air. So when the water vapor on air, the pressure exerted by water vapor on air when it is saturated, it is known as saturation vapor pressure. Now absolute humidity. Absolute humidity is defined as the amount of water vapor contained in given volume of air at a given temperature. So its unit is important, gram per meter cube. So it is the water vapor which is contained in a given volume of air, absolute humidity. Now humidity mixing ratio. Humidity mixing ratio is defined as the mass of water vapor contained in a given mass of air. So when it is coming the mass, it is humidity mixing ratio. So what will be then the humidity mixing ratio for saturated air? It will be the maximum mass of water vapor that is contained in a given mass of air at a particular temperature and pressure. So it is also expressed as gram per kilogram. Now relative humidity. Ratio in percentage of actual vapor pressure present in air to the maximum it can contain at the same temperature and pressure. So that is relative humidity. The term RH we have already discussed in our first or second chapter, I think. So what is RH? RH, it is the relative humidity. So relative humidity in it is the actual means there is a certain amount of water vapor present in air at a particular temperature, that the ratio, it is the ratio in percentage with the actual and the maximum that it can happen, that it can hold. So that is what actual by maximum it can contain. Now next is wet bulb temperature. So it is the lowest temperature which air contains attained by evaporating water into it to saturate it. Desert coolers work on this principle. Drier the air, more effective would be cooling. So what is wet bulb temperature? It is the lowest temperature which air would attain which the air would attain by evaporating water into it to saturate it. So it is the lowest temperature. Okay, so this is the working principle of desert coolers. As the drier the air, more effective would be the cooling. Now dew point temperature. It is the lowest temperature to which air should be cooled at constant pressure to saturate it with respect to water. When we are comparing with respect to water, it is dew point temperature. When we are comparing when we are comparing with evaporating water, it is wet bulb temperature. It is the working principle of desert coolers. Dew point temperature causes condensation. Okay, dew point temperature or dew point is only affected by changing water content, whereas RH, that is relative humidity, is affected by changing water content and temperature both. So different dew point is only affected by the water content. Relative humidity is affected by water content and temperature. Dew point is higher if the air contains more water vapor. By cooling or warming air, relative humidity changes, but dew point does not change. So the factors which affect dew point are only the water content, but the relative humidity is affected by water content and temperature. So temperature is a determining factor of relative humidity, but it is not for dew point. As the dew point is higher, the air contains more water vapor. So what is dew point? It is the lowest temperature at which air should be cooled at constant pressure to saturate it with respect to that of water. So I think it's a bit confusing, but it's okay. But you should remember here that what is dew point? Dew point is only affected by water content, and what is relative humidity? It is the actual by maximum it can hold. So yeah, and relative humidity is affected by temperature also, where dew point is not affected by temperature. So next is frost point. So it is the temperature to which air must be cooled to reach saturation with respect to ice. Cooling below the frost point causes formation of hoarfrost. So it is the temperature which air can be cooled to get as respect to ice. So if it is cooled below the frost point, then it causes the formation of hoarfrost. It is important to note that as temperature of air increases, the amount of water vapor required to saturate is also increases. Okay, that's okay, common sense. At sub-zero temperature, water molecules have more energy and a greater degree of freedom than ice. Consequently, the saturation vapor pressure over water drops is more than that over ice particle. If our water drops and ice particle coexist, water drops will evaporate and condense on the ice particle. The principle is applied in explaining rainfall from clouds which extends above 0 degrees Celsius level in atmosphere and have both supercooled water drops and ice crystals coexisting. So just read it and keep it. Okay. Small water drops can exist in supercooled state in cloud up to minus 40 degrees Celsius and in CP clouds up to minus 45 degrees Celsius. For saturated air during rain, air temperature is equal to wet bulb equal to dew point. Unsaturated dry bulb temperature will be greater than wet bulb will be greater than dew point. Note that for saturated air temperature, wet bulb temperature, dew point is always constant, or they are all same, but saturated it is not like that. With the increase of temperature, saturation humidity mix ratio also increases. Humidity mixing ratio remains constant when air is lifted adiabatically if there is no addition or removal of water vapor. Humidity mixing ratio remains constant when there is no removal of water vapor or no addition or removal of water vapor. So here what you should note is some of the points that we have discussed, that is frost point, dew point, what is dew point, then relative humidity. These are all some things that you should remember, and just look on the questions which will be discussing in the next video. Or should I discuss in this? Yeah, I think I can discuss this question. So there are only 10 questions remaining. So we can let it be in this video. So first question, that is the ratio in percentage between amount of water vapor present in the air to the amount of water vapor that it can hold at the same temperature, which is relative humidity. Yeah, option B. The temperature to which air be cooled at constant pressure to become saturated is known as. Yeah, if you have carefully listened this video, you will be able. Otherwise, it may quite find confusing whether it is wet, dry, dew. Yeah, so it is the temperature to which air be cooled at constant pressure to be saturated, which is, yeah, dew point. Yes. Now, next. That is option C. Okay. So, next. Free air temperature, wet bulb temperature and dew point temperature are equal when air temperature is 0, when relative humidity is 100%, air temperature is not below 0. It is option B. Yeah, relative humidity is 100%. So, you should be known that when relative humidity is 100%, it is saturated air. Then only you will be able to answer this. Yes. Then on a rainy day, compared to sunny day, the length of runway required is more. Option A. The difference between or the spread between free air temperature and dew point temperature is dash when air is saturated. So when air is saturated, the difference between these will be as low as possible. So it will be least. Okay. The saturation vapor pressure over water is dash than the ice. Saturation water. It is a direct question. It will be more than the ice. As temperature of air increases, amount of water vapor required to saturate also increases. Yeah. The actual amount of water vapor required in a given volume of air at a given temperature is termed as, it is absolute humidity. The actual amount of water vapor contained in a given volume of air at a given temperature is termed as absolute humidity. Then humidity mixing ratio dash when air is lifted remains constant. It is the lowest temperature which air would attain by evaporating water into it to saturate it, wet bulb temperature. So what is wet bulb temperature? It is the lowest temperature which air would attain by evaporating water into it to saturate it. So that's it. 10 questions, very simple chapter, very short chapter. So thank you for watching. If you are new to channel, do subscribe. Thank you.